If the diene was cyclic, then this will lead to the formation of bridged bicyclic systems. So for example, if we were given this cyclic diene and we were supposed to react it with this one, then how do we draw the products in this case? First of all, make sure to know that those two are bonds to the inside. So if you have any other branches at these two carbons, those should be dashed. But how do we draw the product? The easiest way to draw the product for this kind of reactions is the following one. Just redraw the diene again here, but make sure to move the double bonds so that you end up with the double bond being at this position. This is again because of the arrow pushing which takes place. So these are the terminal carbons of the diene. And draw the dienophile next to the diene. And again, just keep one of the bonds. So remove one of the bonds. Just make sure to keep only one bond. This is the NO2 group. And all what you have to do is connect this carbon, so the terminal carbon of the diene, with that of the dienophile. And the same thing goes in here, and this is how we draw the product. Now, of course, you can transform this into the bridged bicyclic system form by drawing it in this way. The double bond will be here. Those are the base carbons. This is the bridge, which is this one, and then this is a group, the NO2 group. If the cyclic diene was a 5-membered ring, then your bridge will have only one carbon. So when I draw this again, just draw it as it is, move the new bond, the pi bond, to a new position. This is your dienophile, just put it next to it. Make sure to just keep one bond because the other one will be used for making the sigma bond. And remember, the mechanism is always starting from any of the pi bonds. Just this goes here and this leads to the formation of this bond. And then when this opens up and hits this carbon here, this leads to the formation of the second bond. And then by pushing this to go here, this leads to the formation of a pi bond. Finally, just put the NO2 group. And again, regarding the stereochemistry, just put it as a dash to make sure you are drawing the endo product, and you can draw the wedge one if you are drawing the exo product. To draw the cyclic system, now this is a bridge with only one carbon. So this is a bridge with only one carbon, and then move. So this is your 5-membered ring. Again, those are the base carbons of the diene, which are this one and this one here. This is your bridge, the double bond goes here, and then this is the rest of the molecule. Now, this is the basic structure, or the basic method for doing the structure of the products of cyclic dienes. If we have cycles as branches at the diene or the dienophile, whether they are cyclic or not, then this is just going to lead to the formation of multiple cycles. For example, let's say we were given this compound and we were asked to draw the structure of the product. First of all, make sure that to look at your diene, this is not a cyclic diene because your double bonds are to the outside of the cycle and they are not closed from this side. So again, just draw a 6-membered ring, move the new pi bond to the new position, which is this one, and then just add the remaining groups as branches. So again, 1, 2, 3, 4, 1, 2, 3, 4. As you can see here, between 2 and 3, We have a 6-membered ring, so this is a 6-membered ring which is just acting as a branch. And then at carbons 5 and 6 we have this second cycle which is connected to 5 and 6, and this is the product. Now, to show the stereochemistry here and to make sure that you are drawing the endo product, if they ask for the endo product, you have two options: either to just put dashes here, or just make sure to leave this as it is and then draw the hydrogens at this position, but make sure to draw them as wedges, which will mean that the other bond, which is this one or this one, will be dashes. And this will make sure that you are drawing the endo product. If your diene, let's say, was cyclic again, and your dienophile was also cyclic, then follow the strategy which we used for drawing the products of cyclic dienes. So, one more time, just redraw your diene and make sure to move the double bond to this new position. Those are the terminal carbons of the diene. So those are the terminal carbons of the diene. This is your dienophile. Just draw it as it is. Just make sure to get rid of the pi bond. And now connect this carbon to this carbon and this carbon to this carbon. Again, to draw it in the bridged form, this will be the bridge, which consists of two carbons, and then I will just draw those two bonds. This is the diene part, and then so those two are those two, and then close the cycle. This is, let's say, 5 and 6, so those are 5 and 6, and now I just have to complete the structure by drawing these bonds. And this is how we draw the products of a Diels-Alder reaction. So the most important thing is that you have to pay attention to the stereochemistry at these two carbons here and the stereochemistry at these two carbons here, in addition to paying attention whether your diene is already a cyclic diene or not, so that you know if you have to draw a bridged product or not.